Okay, so we're talking about factors affecting equilibrium. Remembering that systems at equilibrium have got a Kc value. What was that, Skylar? Nothing? Good, because you're my first interruption. So, factors when they're at equilibrium, it's about the ratio between the products and the reactants. Okay, so if you've got a system that's equilibrium and it has a large Kc, you have more products than reactants. If you have a system that's at equilibrium and it has a low Kc, so less than 1, it's still more than 0, less than 1, it will have more reactants than products. These 4 factors will affect a system at equilibrium, and temperature is the only value that can change Kc. It's not going to work for me. Here we go. So, temperature. The impact of temperature on an equilibrium will depend on whether the forward reaction is endothermic or exothermic, and whether the temperature is increased or decreased. Any equilibrium question you need to answer, or put somewhere in your answer, systems act to minimise change. So, if a system is heated, the endothermic reaction is favoured because the system will cool, or it will absorb that extra energy. Okay? If a system is cooled, the exothermic reaction is favoured because the exothermic reaction releases that heat energy and overcomes the cooling. So for example, if we've got this reaction and it has a negative delta H, so it is an exothermic reaction in the forwards direction, if you cool the mixture down, the colour will darken. Okay, because the colour will darken because the forwards reaction will act to minimise the change because you're cooling it down, so the exothermic reaction will be favoured to release that heat energy. Okay, so more of this NO2 will be made because that is the exothermic direction, and that will change the colour. The colourless gas of the O2 doesn't matter, okay, because this side is completely colourless, this side is brown, so it's only that brown gas that's going to be impacting the colour change. An example of this from your exam, so this is the 2018 exam, is when a reaction is carried out at 450 degrees, the Kc value is higher than when the value is at 600. Okay, so to answer that question, we need to understand that a bigger Kc equals more products. Okay, so there's more products when we've got something happening at 450 degrees than when there's 600. So if we've got more products when it's cooler, do you think it's an endothermic reaction or an exothermic reaction? Exothermic reaction, because we're making more products as it cools down, so it's trying to minimise the change. So to answer that question, see if I can get my pen to change colour, you need to have systems act to minimise change. Okay, the 450 is cooler than 600. Okay, so that's a little piece of information that you need to gather there. And the Kc is higher. So the Kc being higher, it means more products. Okay, minimising that change means that it is releasing heat energy. So that means heat energy needs to be released. So heat energy released, which means exo is favoured. And if more products are made by that exothermic reaction being favoured, that means that the product reaction or the forwards reaction, product reaction is exothermic. Okay, so there's actually sort of 3 distinct pieces of information you need to link there. The first is systems act to minimise change. The second is that a bigger Kc equals more products. The third is that 600 degrees is hotter than 450 degrees. I know it sounds like, you're an idiot, but you need to state that clearly to the marker to show you've understood that it's been cooled down. Okay? And then whether the oxidation of sulfur dioxide gas, that actually the information's in the previous question. So you just say it's one or the other. Okay? And so the 2-trioxide, because this, you can even tell from this that that's the product. Okay? It's going to be exothermic. All right, these are always a temperature question, always. And you need to do well in that question, you need to have that understanding from 2.4, atomic structure and bonding, about endothermic and exothermic reactions and those energy transfers. Okay, so we're talking about factors affecting equilibrium. Remembering that systems at equilibrium have got a Kc value. What was that, Skylar? Nothing? Good, because you're my first interruption. So, factors when they're at equilibrium, it's about the ratio between the products and the reactants. Okay, so if you've got a system that's equilibrium and it has a large Kc, you have more products than reactants. If you have a system that's at equilibrium and it has a low Kc, so less than 1, but still more than 0, less than 1, it will have more reactants than products. These 4 factors will affect a system at equilibrium, and temperature is the only value that can change Kc. Okay. A second factor affecting equilibrium is pressure. Okay. And so the impact of pressure on a system at equilibrium will depend on how many molecules are on either side of a reaction, and whether the pressure is increased or decreased. And that can sometimes, or is usually actually, on the volume. Okay, so if you put things in a bigger volume or a bigger container, then the pressure will decrease because there's more space for those molecules to be in. Okay, again, you need that understanding. Systems at equilibrium act to minimize change. So if pressure is increased, the reaction producing the least number of moles is favored. If the pressure is decreased, the reaction producing the most moles is favoured. So you need to look at the stoichiometry of your reaction. So in this one, you can see on this side, we've got 4 molecules because we've got 1 molecule of nitrogen and 3 molecules of hydrogen gas. On this side, we've got 2 molecules, okay, because we've got the 2 ammonia molecules. So if the pressure was increased, the equilibrium will be product favoured, as there are less molecules on the product side. Okay, so you need to look at the specifics for each reaction. Occasionally there are holes, okay, and they put in something that's got 2 molecules on one side and 2 molecules on the other. And so an increase in volume or an increase in pressure or decrease in pressure won't matter because both sides have got the same. So just be aware that that sometimes pops up. So here's an exam question with those ideas in it. So here's an example, it's 2018, like the temperature one that we just did with the sulfur dioxide going to sulfur trioxide. So predict using equilibrium principles the effect on the concentration of sulfur trioxide gas, carrying out the reaction in a larger reaction vessel. So on this side, we've got 2 molecules of sulfur dioxide and 1 molecule of oxygen. So this side's got 3 molecules. This side with the sulfur trioxide only has 2. Okay, so if we use a larger reaction vessel, that's going to mean more volume, which means less pressure. Okay, the system will act to minimize change. Always put that sentence in there, please. Sometimes it's enough to get you an achieve tick. All right, not always, but often. Okay, so to minimize change, so it will try and increase the pressure. So the side with more molecules is favoured. So it will be the reactant side. And then to make sure you're getting that little last excellence tick, you would need to say, so less SO3 made. Okay, just because you're linking it back to the equation or linking it back to the example you're given. So again, you need to determine whether there's more or less volume, so more or less pressure. Then you need to figure out which side, the products or the reactant sides, have got more or less molecules. Think about how the system will act to minimize change. So if pressure is being increased, it will try and decrease the pressure by making less molecules. If the pressure is being decreased, it will try and increase the pressure by making more molecules. Okay? Okay, so we're talking about factors affecting equilibrium. Remembering that systems at equilibrium have got a Kc value. What was that, Skylar? Nothing? Good, because you're my first interruption. So, factors when they're at equilibrium, it's about the ratio between the products and the reactants. Okay, so if you've got a system that's equilibrium and it has a large Kc, you have more products than reactants. If you have a system that's at equilibrium and it has a low Kc, so less than 1, but still more than 0, less than 1, it will have more reactants than products. These 4 factors will affect a system at equilibrium, and temperature is the only value that can change Kc. Third most important, or the third of the big 3 affecting equilibrium is concentration. Okay, so concentration of your reactants and products. So the impact of concentration on an equilibrium will depend on what concentration is being changed, whether the concentration of the products or the reactants is changed. And this can be changed by adding or removing a species, and that can sometimes be a little bit complicated, because if you remove some products, then you are increasing the ratio of the reactants. Okay, so sometimes that balance can be a little bit difficult to ascertain. So systems will act to minimize change. So if a product is increased or reactant decreased, the reactant reaction is favored. If the product is decreased or the reactant is increased, the product reaction is favored. So if we think about another example, I should have made this positive, that's all right. We've got the colourless and the brown. If we add more oxygen, okay, so if we add more oxygen in here, okay, the oxygen is a product, so we're increasing the concentration of our product. We're going to drive that reaction back towards the reactants, and the colour would fade, okay, because we've got less products we'd need to make, because we've got more products, we need to get less products, so we make more reactants. Again, 2018 exam question about the sulfur dioxide trioxide. Okay, explain using equilibrium principles why it is important for an industrial plant to continue to remove the sulfur trioxide gas as it is produced. Okay, so the system is at equilibrium. It will act to minimize change. So if you remove products, it will act to make more products. Okay, and so that will keep the equilibrium pushing in a product direction rather than the reaction stalling when you're getting products and reactants made at the same rate. So it means that overall you will make more sulfur trioxide gas. Okay, so that's quite a simple one, and it's economics. It comes into a lot of that industrial chemistry all the time about balancing how much you have to have the temperature, because obviously temperature increases reaction rates, but it can also negatively impact equilibriums. So how are you going to make sure that your reaction is proceeding fast enough to be economically viable while still making enough of your product? Okay, and same with this, if you just let this equilibrium sit there, you're going to be paying for a big vat of chemicals and you're not actually making any more SO3. So you need to be siphoning off or removing your product to make sure that you push the equilibrium to make more product. Okay, so it makes more products, get more SO3 gas. Okay, and then, okay, so we're talking about factors affecting equilibrium. Remembering that systems at equilibrium have got a Kc value. What was that, Skylar? Nothing? Good, because you're my first interruption. So, factors when they're at equilibrium, it's about the ratio between the products and the reactants. Okay, so if you've got a system that's equilibrium and it has a large Kc, you have more products than reactants. If you have a system that's at equilibrium and it has a low Kc, so less than 1, but still more than 0, less than 1, it will have more reactants than products. These 4 factors will affect a system at equilibrium, and temperature is the only value that can change Kc. Lastly, and it hasn't actually come up in exams for a little while, which is nice, I have to go back to 2015, but factors affecting equilibrium can be a catalyst. Okay, so Catalysts don't change in equilibrium, but if they are present, a system will reach equilibrium faster. So it just means that those forwards and backwards reactions will occur faster, so the changes will be faster. And so back to 2015 to find an exam question about this. So we've got ethanoic acid and ethanol making an ester, ethyl ethanoate and water. Okay, so again, explain using equilibrium principles the effect of adding more ethanol. So that's a concentration question. So if we add more ethanol into here, the ethanol is a reactant. If we increase the concentration of reactants, we'll make more products. So we'll push that equilibrium towards the products and make more products. And then the reaction part down here, the reaction is quite slow, so a small amount of concentrated sulfuric acid is used as a catalyst. Explain, using equilibrium principles, the effect of adding this catalyst to the equilibrium mixture. And this is almost a trick question, okay? Because the catalyst won't change the equilibrium. It just means it will reach equilibrium faster. Okay, so if you get a question like this, all you need to put is the equilibrium won't change, but the reaction, or but the system, let's say, system is probably a better word, will reach equilibrium faster due to the catalyst. How do catalysts work? Providing an alternative pathway. Okay, the catalyst providing an alternative. And I'm going to run out of room, so I'll put it up there, pathway. Okay, so hopefully that's given you a bit of an overview of how those four things work. Hopefully this recording has worked, so you can go through and listen to me do it again if you need to. I'd also recommend pausing at the start of the exam questions and giving them a go yourself, and then comparing them to my answers. Okay? Okay, so we're talking about factors affecting equilibrium. Remembering that systems at equilibrium have got a Kc value. What was that, Skylar? Nothing? Good, because you're my first interruption. So, factors when they're at equilibrium, it's about the ratio between the products and the reactants. Okay, so if you've got a system that's equilibrium and it has a large Kc, you have more products than reactants. If you have a system that's at equilibrium and it has a low Kc, so less than 1, but still more than 0, less than 1, it will have more reactants than products. These four factors will affect a system at equilibrium, and temperature is the only value that can change Kc.